Okay, so this is the 8th question of the Pure Mathematics Paper 1, Variant 2, June 2011. Please have the question in front of you. This is question 8 we're doing. So question 8 says, relative to the origin O, the position vectors of points A, B, and C are given by OA. This is vector notation, this arrow above here, is 2, 3, and 5. OB is 4, 2, and 3. And OC is equal to 10, 0, 6. This is a 10. So, how do we do this problem? Now, we have to find the angle ABC. The angle ABC. Angle is this, A, B, and C. Let's make it full screen. Now, how do we do this? Now, there's an important thing. Now, this uses a concept called a dot product. The dot product always says the magnitude, let's take it in this example, the magnitude of AB into the magnitude of BC, sorry, not magnitude of BC, the magnitude of CB, to take the vectors from both ends, into cos of theta, that is the angle between OA and OC. That is the angle AB and C, is equal to the I component. Now just to remind you, this component over here is the I component or the X component. This component over here is the J component or the Y component. And this one is the K or the Z component. It applies to all vectors. Is equal to the I of the first vector. So this is equal to the I of the first vector, that is AB, into I of the second vector, that is CB, plus J of the first vector. This J is supposed to be small case, J of the first vector into J of the second vector, and so on. Again, this is lowercase. Now let's do this. How do we find AB? In this case, AB, the vector AB is always equal to, take the second letter OB, take the second letter and put OB in it, that's the position vector OB, minus take the first letter OA. This is just vector notation. And the vector CB is just OB, take the second letter, minus OC, take the first letter. Now, how do we do this? So, AB is equal to OB minus OA. How do we do this? We take the components and subtract them. So, the OBI component, that is 4, minus the OCI component, that is 10. 4 minus 10 is minus 6. Except we're doing OA and OB, my bad. So, we take OB, 4, and the I component of OA, 2, and 4 minus 2 is equal to 2. So, we have 2. We do the same for J, that is 2, 2, and 3, 2 minus 3, minus 1. And we do the same for K, 3 minus 5, minus 2. This is AB. Now, CB is equal to OB minus OC. The same method, 4 minus 10, minus 6, 2 minus 0, 2, and 3 minus 6, minus 3. Now, we use the formula that we came up with. That's the dot product formula. That is this formula over here. Now, I hope you've taken this down. I'll just erase this. I'm going to clear the page. Now, we first find the magnitude of AB. Now, magnitude of AB is done by the Pythagoras theorem. That is, in this case, it will be 2 squared plus minus 1 squared plus minus 2 squared root. It's exactly the method that you use for Pythagoras theorem, which is equal to 4 plus 1 plus 4 root 3. Now we want to find the magnitude of CB. And this is equal to root of minus 6 squared plus minus 2 plus 2 squared plus minus 3 squared. So 36 plus 4 plus 9, same method as usual. Root of that is 7. I didn't write this, but I think you know where I'm going with this. Now, our dot product formula was magnitude of AB into magnitude of CB into cos theta. So 7 into 3 into cos of theta, that's the angle between them, is equal to the product of the components. That in this case, it'll be 2 into minus 6. This is an I component, this is an I component. So let's do that. So 2 into minus 6 is minus 12, plus minus 1 into minus 2 is minus 2, plus minus 2 into minus 3 is plus 6. So 21 cos theta is equal to minus 12 minus 2 plus 6, which is minus 8. So theta is equal to cos inverse, I hope you see how I got that, of minus 8 by 21. Minus 8 by 21, cos inverse of answer will equal to 112 degrees. So our theta, I'm going on to this page, is equal to 112.4 degrees. Now remember, when you get problems like this, always remember what the dot product formula is. You have many they'll give you at least maximum 3 to 4 vectors. So make sure you take the correct side. Now if you had done this problem like this, let me clear this page. If you had done this problem like this, taking the magnitude of, you had OA, OB, and OC, and if you had found AB, vector AB, let me just draw the vector signs for this, and you had found the vector BC, and you had done the same method, you would have gotten another answer. You would have gotten, I think you would have gotten 67 degrees. If I'm not mistaken, you can check that. It may be wrong. But you would have gotten another angle, and this is completely wrong. Completely wrong. So make sure you get the correct directions. When you have three positional vectors like this, this, and this, OA, this is O, OA, OB, and OC, and you want to find the angle ABC, that is this and this. You want to find this angle, correct? Make sure you take the vector AB, that is AB, and CB, and you take the magnitudes of that, multiply it, and use a regular dot product formula. There'll be many problems like this, so make sure you learn this concept well. There's also a lot of help in a certain textbook. I can tell you that in the next lecture.